My dear students, this is B. Ramarao from SRRS Government Polytechnic, Sirsilda. General Chemistry from first year diploma students. Subject code C104. Now we discuss about normality, molarity, and relation between molarity and normality. Molarity and normality. In this hour, we discuss about normality, molarity, relation between molarity and normality. Molarity and normality. In this hour, we discuss about the topics objectives. On the completion of this period, you would be able to know. On the completion of this period, you would be able to know. Calculate the weight of solute in normal solution. Calculate the weight of solute in a normal solution. Normal solution. State dilution law. State dilution law. Understand the principle of neutralization. State the relation between molarity and normality. Define mole fraction. Calculate the mole fraction of solute and solvent. Solute and solvent. On the completion of this period, you would be able to know, calculate the weight of solute in a normal solution. Solute in a normal solution. State dilution law. Understand the principle of neutralization. State the relation between molarity and normality. Define mole fraction. Calculate the mole fraction. Calculate the mole fraction of solute and solvent. In the completion of this period, you would calculate the molarity, normality, mole fraction, and relation between molarity and normality. Recap. In the last period, we learned about normality. Can you recall definition of normality? It is defined as the number of gram equivalent of a solute present in 1 liter of solution. Gram equivalent of solute present in 1 liter of solution is called normality. Can you give equation of normality? Normality is equal to weight by gram equivalent weight into 1000 by B in ml. Weight by gram equivalent weight into 1000 by B in milliliters. Normality. What is normality? Normality is defined as the number of gram equivalents of solute present in 1 liter of solution. What is gram equivalent weight? The weight of the substance that react with 1 gram of hydrogen is equal to equivalent weight of the substance. That much quantity of the substance dissolved in 1 liter of solution is called normal solution. So this normality can be calculated by number of gram equivalent weights by volume of solution in liters. Gram equivalent weight can defined by weight by gram equivalent weights into 1 by B in liters. In case given solution volume in milliliters, weight by gram equivalent weight into 1000 by V in milliliters. That is calculation of normality. N is equal to W by GEW into 1000 by VML. 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 Where W is equal to weight of solute in solution. Weight of solute in solution. W weight of solute in solution. Gram equivalent weight of solute GEW. Gram equivalent weight of solute particles. V volume of solution in milliliters. V volume of solution in milliliters. Normality. Calculation of weight of solute. The weight of the substance present in a given solution is given by W is equal to normality into gram equivalent weight into V in liters. V in liters. The weight of the substance present in a given solution is given by W is equal to normality into gram equivalent weight into V in liters. Normality N is equal to normality GEW gram equivalent weight V volume of solution in liters. Volume of solution in liters. W weight of the substance calculated by using normality N into gram equivalent weight into V in liters. V in liters. In case volume in milliliters, normality into gram equivalent weight into VML by 1000 or by 1000. Normality gram equivalent weight into VML by 1000. Calculation of weight of the substance by using this formula. W is equal to normality into gram equivalent weight into V in liters. Volume of solution in liters. Calculation of weight of solute. Problem. How much of sodium carbonate is required to prepare 500 ml of 0.02 N solution given gram molecular weight of sodium carbonate is 106? How much sodium carbonate weight of the substance required to prepare 500 ml 0.02 N solution given gram molecular weight of sodium carbonate is 106. 106. How much of sodium carbonate is required to prepare 500 ml of 0.02 N solution? Given gram molecular weight of sodium carbonate is 106. 106. Calculation weight of sodium carbonate present in 500 ml of 0.02 N normal solution. Data given: normality 0.02 N, gram equivalent weight is equal to gram molecular weight by charge on cation. Therefore, 106 by 2, that is equal to 53. Gram molecular weight 106, gram equivalent weight of sodium carbonate 53. Gram molecular weight by charge on cation or anion. Therefore, 106 by 2, 53 gram equivalent weight. Volume of solution 500 ml or 0.5 liters. 0.5 liters. Calculation of weight of the substance. Formula: W is equal to normality into gram equivalent weight into V in liters. V in liters. Therefore, hence W is equal to 0.02 into 53 into 5, 0.5. That is equal to 0.53 grams of sodium carbonate dissolved in 500 ml of solution, then form 0.02 N normal solution. The weight of sodium carbonate calculated by using 0.02 and 500 ml of 106 gram molecular weight of the substance of sodium carbonate dissolved 0.53 grams of 500 ml of solution, then form 0.02 n normal solution. Normal solution. Neutralization reaction. Neutralization reaction. Principle. In neutralization reaction, 1N acid is completely neutralized by 1N base irrespective of their acidities or basities. In neutralization reaction, 1N acid is completely neutralized by 1N base irrespective of their acidities or basities. In neutralization reaction, 1N acid is completely neutralized by 1N base irrespective of their acidities or basities. If a solution of normality N and volume V1 is neutralized by another normality of solution N2 and volume of solution V2, then they are related by the equation 1N acid completely neutralized by 1N base irrespective of their acidities or basities. If a solution of normality N1 and volume V1 is neutralized by another normality N2 and volume V2, then they are related by the reaction. Then the equation is N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. Neutralization reaction N1 V1 is equal to N2 V2. In neutralization reaction, 1N acid is completely neutralized by 1N base irrespective of their acidity and base. First solution normality N1, volume V1. Second solution normality N2, volume V2. Then relation between first and second solution is N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. One can calculate either volume or normality of one of solution knowing the corresponding. One of the solution is knowing the corresponding. Values of the other form the above equation. Values of the other form. The above equation. Problem. 50 ml of 0.2N H2SO4 solution is neutralized by 75 ml of NaOH solution. What is the normality of NaOH? 50 ml of 0.2N H2SO4 solution completely neutralized by 75 ml of NaOH solution. What is the normality of NaOH? One is acid and the other one is base. These two neutralized by using 50 ml acid, 75 ml base. Acid normality 0.2N, base normality how much? Then H2SO4 volume 50 ml, H2SO4 normality 0.2. It is neutralized by 75 ml of NaOH solution. What is the normality of NaOH? 50 ml of 0.2N H2SO4 solution is neutralized by 75 ml of NaOH solution. What is the normality of NaOH? Data given by Volume of H2SO4 V1 is equal to 50 ml. Volume of NaOH VT is equal to 75 ml. H2SO4 volume 50 ml, NaOH volume 75 ml. Normality of H2SO4 N1 is equal to 0.2 n. Calculate the normality of NaOH. Volume of H2SO4 50 ml. Volume of NaOH V2 is equal to 75 ml. Normality of H2SO4 N1 is equal to 0.2 n. Then calculate the normality of NaOH N2 is equal to how much? N1 V1 is equal to N2 V2. Then N2 is equal to N1 V1 by V2. N1 0.2, V1 50 by 75, then you got N2 value. Then formula N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. Then N2 is equal to N1 V1 by V2. N1 V1 by V2. 0.2 N1, V1 value 50 ml, V2 value 75. 0.2 into 50 by 75. Then you got normality of NaOH 0.133 n. Hence, normality of NaOH solution is 0.133 n. 0.133 n. Dilution law. Dilute solutions are prepared by adding water to concentrated solution. Adding water to concentrated solution. Dilution law using dilute solution are prepared by adding water to concentrated solution. If a solution of normality N1 and volume V1 is diluted to a normality N2 and volume V2, then the following equation holds good. N1 V1 is equal to N2 V2. Dilute solution are prepared by adding water to concentrated solution is called dilution law. If a solution of normality N1 and volume V1 is diluted to a normality N2 volume V2, then the following equation holds good. N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. The amount of water added to is given by V2 minus V1. The amount of water is added to V2 minus V1. The amount of water is added to V2 minus V1. If a solution of normality N1 and volume V1 is diluted to a normality N2 and volume V2, then the following equation holds true. N1 V1 is equal to N2. The amount of water added is given by V2 minus V1. Problem. What is the volume of water to be added to 500 ml 1N solution, 1N sodium carbonate solution so as to make it has 0.1 n. What is the volume of water to be added to 500 ml 1N sodium carbonate solution so as to make it has 0.1 n. Data. Volume of concentrated solution 500 ml. Normality of concentrated solution N1 is equal to 1N. Normality of dilute solution N2 is equal to 0.1 N. Calculate the volume of dilute solution V2 is equal to how much? V2 is equal to how much? What is the volume of water to be added to 500 ml 1N sodium carbonate solution so as to make it as 0.1 N solution? 1 into 0.1 N concentration change by adding water. Volume of given concentrated solution V1 is equal to 500 ml. Normality of concentrated solution 1N. Normality of dilute solution 0.1 N. Volume of dilute solution V2 is equal to how much? Then formula N1 V1 is equal to N2 V2. N1 V1 is equal to N2 V2. N1 V1 is equal N2 V2. For this, V2 is equal to N1 V1 by N2. N1 V1 by N2. 500 into 1 by 0.1, that is equal to 5000 ml. Volume of V2 is equal to 5000 ml. N1 V1 is equal to N2 V2. Therefore, V2 is equal to N1 V1 by N2. 1 into 500 by 0.1, that is equal 5000 ml. V2 is equal, final volume of V2 is equal 5000 ml. The water to be added to this given concentrated solution V2 minus V1, 5000 minus 500, 4500. Volume of water to be added V2 minus V1. Volume of water to be added 4000 minus 500, that is equal 4500 ml of water to added 500 ml of 1N concentrated solution convert to 0.1N solution. Relation between molarity and normality. Molarity and normality are related as molarity into gram molecular weight is equal to normality into gram equivalent weight. Molarity into gram molecular weight is equal to normality into gram equivalent weight. GMW, gram molecular weight. GEW, gram equivalent weight. Knowing any three values, the fourth value can be calculated from the above equation. For acids, normality is equal to molarity into basicity of acid. Normality is equal to molarity into basicity of acid. For bases, normality is equal to molarity into acidity of base. For acids, normality is equal to molarity into basicity of acid. For base, normality is equal to molarity into acidity of base. For redox reagents, normality is equal to molarity into charge in oxidation state. For acid, normality is equal to molarity into basicity of acid. For bases, normality is equal to molarity into acidity of base. For redox reagents, normality is equal to molarity into charge or change in oxidation state. Problem. Molarity of H2SO4 is 2N. What is normal? H2SO4 acid. This acid basicity is 2. Therefore, normality is equal to molarity into basicity of H2SO4, 2 into 2, that is equal to 4N. Molarity of H2SO4 is 2m. What is the normality of 2m H2SO4 solution? Data. Gram molecular weight of H2SO4 is 98. Gram equivalent weight of H2SO4 is equal to 49. Molarity is equal to 2m. What is normal? Formula: molarity into gram molecular weight is equal to normality into gram equivalent weight. Gram equivalent weight. Therefore, normality is equal to molarity into gram molecular weight by gram equivalent weight. 98 into 2 by 49, that is equal to 4n. Molarity into gram molecular weight is equal to normality into gram equivalent weight. Therefore, normality is equal to molarity into gram molecular weight by gram equivalent weight. 2 into 98 by 49, that is equal to 4n. 4n. Normality and molarity relation. Molarity: number of moles of solutes present in 1 liter of solution. Therefore, M is equal to number of moles of solute by volume of solution. Moles of solute by gram molecular weight of solute by solute into 1000 by Vml. Therefore, number of moles is equal to molarity into volume of solution in liters. Millimoles is equal to molarity into volume of solution in milliliters. Concentration of solution: normality is equal to number of equivalents of solutes present in 1 liter of solution. Therefore, normality is equal to equivalent of solute by volume of solution in liters. Therefore, N is equal to mass of solute by equivalent mass of solute into 1000 by V in milliliters. Also, N is equal to equivalence weight of solute by volume of solution in liters. Therefore, equivalent weight of solute is equal to normality into V in liters. Milli equivalence weights of normality is equal equivalent weight is equal to normality into volume of solution in milliliters. Equivalent mass of acid. Equivalent mass of acid: molecular mass of acid by number of replaceable H plus ions, that is basicity. The ratio between gram molecular weight and its basicity is called equivalent weight of acid. What is basicity? How many number of H plus ions replaced from acid is called basicity. How many number of H plus ions replaced from acid is called basicity. Example: equivalent mass of HCl and H2SO. HCl basicity is 1. It replaces only 1 H plus ion. H2SO4 basicity is 2. It replaces 2 H plus ions. So its basicity is 2. Then equivalent weight of HCl is equal 36.5 by 1, that is 36.5. Equivalent weight of H2SO4, 2 H plus ions and 1 sulfur, 4 oxygen present. 2 into 1 plus 32 plus 4 into 16 by 2, that is equal 98 by 2. Then you got 49 gram equivalent weight of H2SO4, 49. The ratio between gram molecular weight and its basicity is called equivalent weight of acid. HCl equivalent weight 36.5, H2SO4 equivalent weight 49. Equivalent weight of base. The ratio between gram molecular weight and its acidity is called equivalent weight of base. Equivalent weight of base. The ratio between gram molecular weight and its acidity is called equivalent weight of base. Equivalent weight of base is equal gram molecular weight by number of replaceable OH minus ions from base is called acidity. For example, equivalent weight of NaOH and calcium hydroxide. NaOH and calcium hydroxide. NaOH, Na plus OH minus. It replaces only one OH minus, then acidity of NaOH is equal to 1. Calcium hydroxide Ca plus 2 plus 2 OH minus. It replaces 2 OH minus ions, then calcium hydroxide acidity is 2. Equivalent weight of NaOH is equal to 23 plus 16 plus 1 by 1. 40 by 1, that is equal to 40. Sodium hydroxide. It replaces only one OH. Then acidity of NaOH is 1. Gram molecular weight of NaOH 40 by 1, that is equal to 40. 40 by 1, 40. In case calcium hydroxide, it replaces 2 OH minus ions from calcium hydroxide, then acidity of calcium hydroxide is 2. Calcium hydroxide acidity is 2. Equivalent weight of calcium hydroxide is equal to 1 calcium, 2 oxygens, 2 hydrogens are present. Calcium atomic weight 40, 2 into 1 hydrogen plus 2 into 16 by 2. 74 by 2, that is equal to 37. The ratio between gram molecular weight and its acidity is called equivalent weight of base. How many number of OH minus ions replaced from base is called acidity. NaOH acidity is 1, calcium hydroxide acidity is 2. Equivalent weight of NaOH 40 by 1, that is equal to 40. Equivalent weight of calcium hydroxide 74 by 2, that is 37. Equivalent weight of salt. The ratio between gram molecular weight and its charge on cation or anion is called equivalent weight of salt. Equivalent weight of salt. The ratio between gram molecular weight and its charge is called equivalent weight of salt. Equivalent mass of sodium chloride and magnesium chloride. Sodium chloride Na plus Cl minus. Charge on cation is 1, charge on anion also 1. Then equivalent weight of sodium chloride 23 plus 35.5 by 1, that is 58.5 by 1. Magnesium chloride Mg plus 2 plus 2 Cl minus. Charge on cation is 2, therefore magnesium chloride 2 magnesium atoms plus 2 chlorine atoms. 1 magnesium, 2 chlorine. 1 magnesium and 2 chlorine. Magnesium atomic weight 24 plus 71 by 2, that is equal to 95 by 2, 47.5. 47.5. The ratio between atomic gram molecular weight and its charge. Sodium chloride charge 1, magnesium chloride charge 2. Therefore, equivalent weight of sodium chloride 58.5 by 1, that is equal to 58.5. Magnesium chloride charge 2, 95 by 2, that is 47.5. 1 magnesium 24 plus 2 into 35.5, 24 plus 71, that is 95 by 2. 47.5. The relation between normality and molarity. Normality is equal mass of solute by molar mass by n factor 1000 by V in ml. Therefore, normality is equal to molarity into n factor. HCl n factor 1, H2SO4 2, H3PO4 3, NaOH1 calcium hydroxide 2. Therefore, normality is equal to molarity into n factor. In case normality of acid is equal to molarity into basicity. Normality of base is equal to molarity into acidity. For monovalent compound n is equal to 1, normality and molarity is same. Normality and molarity is same. Then calculate the molarity of 0.6 N aluminum chloride AlCl3 solution. AlCl3 solution. AlCl3 gives Al plus 3 plus 3Cl minus. That is equal to N is equal to 3, M is equal to 0.6 by 3, that is equal to 0.2 M. 2 M. Calculate the molarity of 0.6 N aluminum trichloride solution. Normality is equal to 0.6 N. Charge on cation is equal to 3. Therefore, normality is equal to molarity into charge. Therefore, molarity is equal to normality by charge 0.6 by 3, that is equal to 0.2 M. Calculate the molarity of 0.6 N aluminum trichloride. AlCl3. Charge on aluminum 3. Normality 0.6 N. Then molarity is equal to 0.6 by 3, that is 0.2 M. 0.2 M. Once again, repeat molarity and normality. Molarity. Number of moles of solute present in 1 liter of solution. Therefore, molarity is equal to number of moles of solute by volume of solution in liters. Molarity is equal to number of moles into 1000 by gram molecular weight into volume of solution in milliliters. Therefore, number of moles is equal to molarity into volume of solution. Number of moles is equal to molarity into volume of solution in liters. In millimoles is equal to molarity into volume of solution in milliliters. In milliliters. Concentration of solution. Normality is equal to number of equivalents of solute present in 1 liter of solution. N is equal to equivalence weight of solute by volume of solution in liters. Therefore, N is equal to mass of solute into 1000 by equivalent mass of solute into volume of solution in milliliters. Also, N is equal to equivalence by V in liters. Equivalence is equal to N into V in liters. Milli equivalence is equal to N into V in milliliters. Equivalent mass of acid. Equivalent mass of acid. Therefore, equivalent mass of acid is equal to molar mass of acid by number of replaceable H plus ions. It is basicity. Equivalent mass of HCl and H2SO4. HCl replace only 1 H plus, H2SO4 replace 2 H plus ions. HCl gives H plus plus Cl minus. H2SO4 gives 2 H plus SO4 minus 2. SO4 minus 2. Therefore, equivalent mass of HCl is equal to HCl gram molecular weight H plus Cl, H atomic weight 1, chlorine atomic weight 35.5 by 1, that is equal 36.5. Equivalent mass of H2SO4, 2 hydrogen, 1 sulfur, 4 oxygen. 2 into 1 plus 32 plus 4 into 16 by 2, that is 98 by 2, that is equal 49. 49. Equivalent mass of base, the ratio between gram molecular weight and its acidity. Therefore, equivalent mass of base is equal to molecular mass by number of replaced OH minus ions is called acidity. Equivalent mass of NaOH and calcium hydroxide, NaOH gives Na plus OH minus. Calcium hydroxide gives Ca plus 2 plus 2OH minus. Then equivalent mass of NaOH is equal 23 plus 16 plus 1 by 1, that is equal to 40. Equivalent mass of calcium hydroxide is equal 1 calcium, 2 oxygens, 2 hydrogens. 40 plus 2 into 16 plus 2 into 1 by 2, that is equal 37. 37. Equivalent mass of salt. Equivalent mass of salt is equal to molecular mass by total number of positive or negative charges. Equivalent mass of NaCl and magnesium chloride. Sodium chloride Na plus Cl minus. Equivalent mass of sodium chloride. Sodium 23 plus 35.5 by 1, that is 58.5 by 1, that is equal 58.5. Equivalent mass of sodium chloride is equal 58.5. Magnesium chloride Mg plus 2 plus 2Cl minus. Equivalent mass of magnesium chloride 24 plus 2 into 35.5 by 2, that is 95 by 2, 47.5. Equivalent mass of salt. The ratio between gram molecular weight of salt and its charge. Sodium chloride, charge on sodium chloride 1, 58.5 by 1, it is equal 58.5. Equivalent mass of magnesium chloride, magnesium 24 plus 2 into 35.5 by 2, that is 47.5. The relation between normality and molarity. Normality is equal mass of solute into 1000 by molecular mass by n factor into volume of solution in milliliters. Therefore, normality is equal molarity into n factor. HCl n factor is 1, H2SO4 n factor 2, H3PO4 n factor 3, sodium hydroxide n factor 1, calcium hydroxide n factor 2, sodium chloride n factor 1, magnesium chloride n factor 2, aluminum chloride n factor 3. What is n factor? Acid n factor means how many number of H plus ions replaced from acid is called n factor. What is base n factor? How many number of hydroxyl ions replaced from base is called n factor of base. What is n factor of salt? How many number of, what is charge on cation or anion is called salt n factor. Therefore, normality is equal to molarity into n factor. Calculate molarity of 0.6 n aluminum chloride. 0.6 n aluminum trichloride. Solution: aluminum trichloride Al plus 3 plus 3Cl minus. Then charge on aluminum 3. Therefore, molarity is equal to normality by charge 0.6 by 3, that is equal 0.2 m. 2 m. Charge on cation 3. Normality 0.6 m. What is molarity? Molarity and normality relation is equal. Normality is equal to molarity into n factor. N factor means charge on cation. Therefore, molarity is equal to normality by n factor. 0.6 by n factor means charge on aluminum 3. Therefore, 0.6 by 3, that is equal to 0.2 m. In this hour, we discuss what is normality, what is the formula of normality, how to calculate the normality given solution, how to calculate the weight of the substance given normal solution. What is molarity? What is molarity? How to calculate the molarity of the solution? How to calculate the weight of the substance given molar solution? What is relation between normality and molarity? How to calculate the equivalent weight of acid, base and salt solutions? This one our topic. Thank you once again.